In this video, we are going to go over the difference between strong acids, strong bases, and weak bases. Okay, and this is going to be an important idea if you continue on in chemistry because there's very few strong acids and there's very few strong bases. Most acids and bases are actually weak, and we want to know what that means to be weak. So, a strong acid is an acid that dissociates 100%, meaning if I have HA, this gives up all H pluses that it has, okay? Where a weak acid is an acid that dissociates less than 5%. So this HA will give up very few H pluses, okay? And so we would see that we have an equilibrium arrow because it doesn't really produce that many products. This produces a lot of products. Bases are the same definition except a base dissociates 100% and produces a lot of hydroxide. So this gives up all of its hydroxides. Where a weak base is one that dissociates, again, less than 5%. And so it gives up very few hydroxides. If we were in class right now, on the wall would be all of your strong acids to know. Okay, so these are the only strong acids that dissociate 100%. And so if we look at a picture, if we have HA, which is an acid, if it's a strong acid, it's going to completely turn into H plus and A minus, okay, with no HA left over. If it's a weak acid or a weak base, we're going to have, our acid or our base, and we're still going to have a lot of it left behind, okay? We're going to still have our weak acid left behind because only 5% of it reacted. Okay, now bases, all strong bases have hydroxide in them. So sodium hydroxide is a strong base. It produces a lot of sodium ions and hydroxide ions. Bases without hydroxide have to react with water because bases will produce hydroxide. If we have, this is called methylamine. And it doesn't have any OH in it, so it has to react with water to produce OH. Because it has no OH in it, we know that this is a weak base. Okay, our strong bases, a good little rule to know for strong bases, are listed here. But if we think about family 1A on the periodic table and family 2A on the periodic table, all lithium, sodium, potassium, rubidium, cesium, and francium, when they're paired with hydroxide, they're all strong bases except for hydrogen hydroxide. So HOH is not a strong base because that's just water. So in family 1A, the first element is not a strong base with hydroxide. In family 2A, we've got calcium, strontium, barium, and then radium hydroxide. Those are all strong bases, but not beryllium and magnesium. So in family 2A, the first two elements are not strong bases. And that's because these guys, beryllium hydroxide and magnesium hydroxide, are insoluble in water. So if we want our base to dissociate, like sodium hydroxide, we put it in water, it gets sodium ions plus hydroxide ions. This can be a strong base because we just produced a lot of hydroxide. Beryllium hydroxide and magnesium hydroxide don't really dissolve in water, so we're not going to see many hydroxides being produced. Okay, So it's very important to know that there's a lot of bases that do not contain hydroxide. So if this bases accept H plus, so instead of NH3, we're going to get NH4 plus 1 plus hydroxide. So by reacting with water, a weak base will still produce hydroxide. Not a lot of it, but it will still produce hydroxide.